Okay, so let's go over your test and see if we can learn from our mistakes. So number one, in the accompanying diagram, parallel lines A, B, and CD are intersected by transversal EF at points X and Y, and the measure of angle FYD equals 123 degrees. Find the measure of angle AXY. All right, so first of all, when it says find the measure of angle AXY, just go ahead and follow those letters A, X, Y. You could even trace them out with your pen. And then we go to the middle letter that's in between AX and XY. And then this is the angle that we're looking for. I'm going to go ahead and label it X. So we're looking for this angle right over here. So to understand this question, to answer it, you need to understand vertical angles, alternate interior angles, corresponding angles, or supplementary angles. So here we have vertical angles. We know vertical angles are congruent. So this 123 is equal to this one right over here. These two are equal to each other. And then we also have alternate interior angles. I always like to show you that by highlighting something like this, a Z or a backward Z. And right over here, this 123 degrees is equal to this angle right over here. That would be angle FXB. So this is also 123. Now to find X, you should recognize that we have a linear pair right over here. Linear pair means these add up to 180 degrees. So all you have to do is 180 degrees minus 123. And what do we get for that? 57. So the answer is 57 degrees. So there's more than one way to do it. Hopefully you can find other ways. I'll show you one more. The other way is to recognize that FYD, this angle here, and angle YXB, these are corresponding angles. So this is also 123. And then you do the supplementary angles like we did before, right? Do 180 minus 123 because these are a linear pair, and then you can get the 57 degrees. All right, number two, what is the largest angle in the accompanying triangle? So the common mistake here that I see is students will solve for X, will try to solve for X, but they will forget to include this one. So just remember that if you're going to solve by writing an equation, make sure you include all three angles. So you got X plus 15 plus 2X plus 1 equals 180 degrees. All right, so yeah, I saw students, some students for some reason forgot to include this X here. So you're going to go ahead and solve for X. X plus 2X, you get 4X plus 16 equals 180. Subtract 16 from both sides. We get 4X equals, what's 180 minus 16? That's going to be 164. Divide both sides by 4. And we're going to get X equals 41. Now, some students did think the answer was 41. It's not 41. The value of X is 41. They want the largest angle. So we know this angle here is 41 degrees, obviously. And then this angle here is going to be 41 plus 15. So that's going to be 56 degrees. And then this angle here is going to be 41 times 2. That's 82 plus 1. That's 83. So the answer is choice 4. All right, here we got another triangle question, and we're told angle BDC. So look, you always want to label, please, if you are given information, label it. So many students miss this question. I think it's due in part to students not labeling given information. So angle BDC is 100 degrees. That's this angle here. label it 100 degrees. Angle A is 50 degrees, label it 50 degrees. And angle DBC is 30 degrees, we label it 30 degrees. Which statement is true? Now look, in order to determine which of these statements is true, you need to find the rest of the angles. So let's go ahead and do that. We know this one here is 80 degrees because we have a linear pair, right? These have to add up to 180. And then here we got 80 plus 50. 80 plus 50 is what? 130. And then you're going to do 180 minus 130. You're going to get 50. So that means this angle here is 50 degrees. So that's 50 plus 50 plus 80, right? 50 plus 50 plus 80 has to give you 180. And then here you got 100 plus 30, that's 130. So that means this angle here is going to be the result of subtracting 180 minus 130, which is 50. So then this guy is 50 here. All right, so let's use some process of elimination. Which statement is true? Triangle ABD is obtuse. So that's referring to this triangle here, triangle ABD. And it's saying it's obtuse. Well, in order for the triangle to be obtuse, one of the angles has to be over 90 degrees, and that's not the case. So it's not obtuse. Then it says choice 2, triangle ABC is isosceles. So let's look at triangle ABC. Let me just go ahead and highlight triangle ABC to make it easier to see which triangle we're talking about. All right, so triangle ABC is talking about that triangle right there, right? Let me make some room here. Another way to look at it is just draw it separately, triangle ABC. So this is 50. 50 plus angle B over here is going to be the addition of 50 and 30, which is 80, and then angle C is 50. And it's saying triangle ABC is isosceles, and you could see that it is isosceles. We know that AB is going to be equal to BC because these two angles are equal to each other. So yeah, it's isosceles. So the answer is choice 2. All right, so number 4, which sequence of transformations will map triangle ABC onto triangle A prime, B prime, C prime? Okay, so look, we know that a dilation took place because the figure ABC changed in size, and then that can only happen to a dilation. So we know that choice 1 and choice 2 cannot be the answer because neither in choice 1 nor in choice 2 do we have a dilation as an option. So the answer is either choice 3 or choice 4. The other thing we need to look at is how did this figure go from this position to the position that we see here. So that's a turn, right? This figure was turned or rotated. So then that means that a dilation and a rotation took place. So the answer is choice 4. So look, we know it was not a translation because in a translation, what you have is a slide, right? So let's say I have a triangle. In a translation, all I'm doing is sliding that figure. So if I just slide it, I will still have, it'll be in a different position, but you could see that it was never turned. And if you actually look at the problem here, you could see that this was turned, right? So it wasn't a translation, it was a rotation. So the answer is choice 4. 5. Describe a sequence of transformations that will map triangle ABC onto triangle DEF. Okay, so the way that I would do this, I understand that to go from here to here, there needs to be a reflection. And the reason I know that is because I can tell that this figure has been flipped, and that's a reflection. So now I have to decide how was it flipped. So and you know, a lot of this is sometimes trial and error. So I'm just going to go ahead and I'm going to say it was flipped across the x-axis. So if I flip it across the x-axis, I'm going to have point A prime right over here. right? I count 3 units from here to point A, so that means A prime should be 3 units away from the line of reflection. And then B prime will be right over here. And then let's see, how far is point C from the line of reflection? 1, 2, 3, 4, 5, 6. So I count 1, 2, 3, 4, 5, 6. So then that's C prime right there. So then now, the next thing is, how do I go from this to that? Well, we talked about this earlier, right? It's like a slide. It's a translation, not a rotation. So so my answer is going to be, so to describe the sequence of transformations, I'm going to say we reflect triangle ABC across the x-axis, which, by the way, that's also the line y equals 0. It's going to come in handy later. We reflect triangle ABC across the x-axis, then we translate how many units to the right. Let's see, 1, 2, 3, 4, 5, 6, 6 units to the right. All right, it's number 5. Number 6. If the pentagon is rotated clockwise around its center, the minimum number of degrees it must be rotated to carry the pentagon onto itself is. So understand this, minimum number of degrees. So of course, right, if you rotate this 360 degrees, of course it's going to map onto itself. Yes, but they're saying what's the minimum number of degrees? So that means there's a smaller angle by which we can rotate that will map the figure onto itself. Now, how do we find that angle? Well, if we just, there's a simple formula, to be honest, and it's just 360 divided by n. And then n stands for the number of sides. So that's going to be 360 divided by 5. The answer is 72 degrees. Number 7. The vertices of triangle JKL have coordinates JKL, under which transformation is the image not congruent. So look, congruent means same size, same shape, same everything. Congruent means equal. So according to this question, the transformation of JKL is not congruent to JKL, right? Triangle J prime, K prime, L prime is not congruent to JKL. So now think, which transformation, there's only one, will produce an image that's not congruent, meaning will change the size? Well, that's a dilation. Only a dilation will change the size. A reflection, you're going to get a congruent image. A rotation, you're going to get a congruent image. A translation, you're going to get a congruent image because they don't change the size. They preserve distance. All right, so number 8, in the diagram below, triangle ABC has coordinates ABC, graph and label, triangle A double prime, B double prime, C double prime. The image of triangle ABC after the translation 5 units to the right and 2 units up, followed by the reflection over the line y equals 0. All right, so first we need to translate this thing. 5 units to the right and 2 units up. So then each coordinate, just translate it. That means slide it 5 units to the right and 2 units up. So let me show you how to do that. So with the A coordinate here, I'm going to translate it 5 units to the right, 2 units up. So I'm going to go 1, 2, 3, 4, 5, and then I'm going to go 2 units up. So then that will put A prime right over here. And then we got C. So same concept. 1, 2, 3, 4, 5, and then 2 units up. 1, 2. So we get C prime here. Let's connect them. Let's fix that up a little bit. Much better. All right, then followed by the reflection over the line y equals 0. Now, Where is the line y equals 0? Well, we know the line y equals 3 is a horizontal line that crosses 3 on the y-axis. Y equals 2 is a horizontal line that crosses 2 on the y-axis. Y equals 1 is a horizontal line like that crosses 1 on the y-axis. So, following that logic, the line y equals 0 is actually the x-axis. So let's go ahead and I'm going to show you that right there. That's the line y equals 0. So it turns out the line y equals 0 is actually the x-axis. Why didn't they just say that? Well, they want to test your ability to decipher what y equals 0 means. So then now we're going to reflect these points across the x-axis. So let's go ahead and do that. So for point B is 2 units away from the x-axis, so count 2 units away on the other side. So you get B double prime here. A double prime, same thing, 2 units away, count 2 units away on the other side. So then that's going to put C double prime here. So let's go ahead and connect those. There is our triangle. Let's fix that up a little bit. All right. Now, so it says graph and label A double prime, B double prime, C double prime. So I graphed it. Points are labeled, but let's just go ahead and state the coordinates. All right. So the coordinates of A double prime, -7. All right, last one. Number 9 in the diagram below, EF intersects A, B, and CD at G and H respectively, and GI is drawn such that GH is congruent to IH. Please, please label that. Label any information you get. GH is congruent to HI. Right there, just from that, we know this triangle is isosceles because 2 sides are equal. So that means this angle, whatever the measure is the same as this angle here. Angle HGI is equal to angle HIG because that's an isosceles triangle. So just from that, I know that information. Okay, then I'm told that angle EGB is 50 degrees. So this is 50 degrees. Angle DIG is 115 degrees. Where's DIG? DIG, right over here, 115 degrees. Find all the angles inside triangle GHI and explain why AB is parallel to CD. All right, so look, just put down everything you know about all these angles. Why not? Right? Doesn't hurt. So what's everything I know? Well, I know these are vertical angles. So this is 50 degrees. I know that these angles right over here, they are supplementary. These angles here I'm talking about. So what's 180 take away 115? That is 65, right? So then that means that this angle here is 65 degrees. So let's write 65 degrees here. Remember we said that these 2 angles are equal because this triangle is isosceles. So let's write 65 degrees here. Okay, now if that's 65 and that's 65, what's the measurement of angle IHG right over here? What's the measurement of this angle here? Well, 65 plus 65 is 130, and 180 take away 130 is 50 degrees. Aha! So this angle is 50 degrees. Now, what does that tell me? Well, let's go back. Let's recall. Remember we said in a lesson that whenever the alternate interior angles are congruent, we will have parallel lines. Remember that? I'm saying this angle here is 50 degrees. You see the alternate interior angles here? They are congruent. So if those 2 angles are congruent, then that must mean that line AB is parallel to line CD. So let's go ahead and write that down. So I'm going to write, since the alternate interior angles are congruent, lines AB and CD are parallel. I realize you can't see that, so I'm going to have to move that up. Okay. So since the alternate interior angles are congruent, lines AB and CD are parallel.